Welcome to Two Projects. In this video, we are going to explain about the project that is the usage of template mining in log file classification. Before getting into the execution, first let us understand what is the project about. Log files. Log files, they are the records created by software systems to document what is happening while the system is running. So these log files they capture everything from routine actions to unexpected errors. Essentially, they serve as a trial of events. For example, when you visit a website, a log file might record things like which page you have visited, how long you have stayed, and if there are any issues like slow loading times or errors. Log files can be generated by almost anything that runs on a computer networks or a network, web servers, operating systems, applications, or even devices. They are crucial for monitoring system performance, troubleshooting problems, and even improving efficiency if a website crashes, for instance. The log file might show what happened right before the crash, helping technicians identify the cause. However, log files are often raw and unstructured. They much like a messy journal. They are not in neat, structured format. This makes it difficult to analyze and extract meaningful insights. This lack of structure can make it hard to understand user behavior, detect anomalies, or even improve the system performance. To make these logs useful, they need to be processed and analyzed carefully, turning all the raw information into something actionable for better decision making. Coming to the existing system, so when it comes to analyzing log files, there are several techniques that have been used, like clustering, machine learning, and deep learning. These methods can be quite effective, but they face some major challenges. One of the biggest problem is that many of these techniques rely heavily on domain specific data, which means they work well for one type of system or environment but struggle when applied to different ones. This lack of flexibility makes them less useful when trying to apply the same analysis to different types of data or across various industries. So another issue is that these methods often don't generalize well across different domains. For example, a model trained on a web server logs might not perform well on logs from an industrial machine or smartphone app. Additionally, many of these techniques are inefficient when it comes to processing real-time log entries, which is crucial for large-scale systems where logs are generated constantly. They also struggle with scalability and adaptability, meaning they can't easily handle the massive amount of data that come with large dynamic systems. These challenges highlight the need for better methods that can process and analyze log files more effectively, transforming all the raw data into something useful, no matter the environment or a scale. So, to overcome all these issues, the proposed system aims to improve the process of classifying log files by making the data easier to work with and more accurate for analysis. Normal log files are unstructured, which means they are hard to interpret directly. The system addresses this by transforming the raw log entries into structured templates. Essentially, it breaks down the log messages into two parts. One is the constant variable components and the other one is variable paths, which can change the depending on situation. So coming to constant paths, they stay the same, but variable paths they change depending on the situation. This helps to standardize the data and make it easier to classify. Additionally, the system uses two sets of features to train the classification models, which are original features, which come from the raw log messages without any filtering, and the proposed features that are obtained after doing some pre-processing on the log files. For example, here we incorporate TF-IDF for pre-processing the text. That is term frequency, inverse document frequency to highlight the most important parts of the logs. And to deal with the issue of class imbalance, synthetic minority oversampling technique, that is SMOT, has been used. This creates synthetic samples to balance the data set. This ensures that the classification models are trained on a more representative set of the data. This improves their performance and also the accuracy. And to classify the log files, we are incorporating k-nearest neighbor, random forest, AdaBoost, and decision tree to see how well they perform on the both original raw log data and refined log data. This means that we are training all these algorithms on the original features as well as the proposed features. To evaluate their performance, we are incorporating precision recall, FN score, and accuracy. So this is about the proposed system. Moving on to the extension part. As an extension of the project, we have introduced MLP to original features and also the proposed features. So as an extension, we are introducing two advanced models that are multi-layer perceptron for the original log features and light GBM for the refined features. Both of these algorithms outperform the classifiers, showing that we use more advanced models and improve the way we process the data. And the results are significantly better. This highlights how we're refining the features and using more sophisticated techniques can really boost the performance and scalability of log classification. And to make the system more practical as the front end, to develop the front end, we have incorporated Flask framework. This allows users to interact with the system easily and also securely. With the user authentication in this project, we ensure that only authorized individuals can access and test the system, making both accessible and also safe to use. To implement this project, we have followed the steps mentioned in the flow of work to execute it. So let us understand what are the steps. First, we have imported all the required libraries and packages such as Pandas, NumPy, Scikit-learn, Flask to support the data processing, machine learning, and the web application development. And then next step is data exploration. This step involves understanding the structure and the content of the data from various sources. So here we have loaded HDFS, OpenSSH, BGL, HPC, Proxyfire health data, allowing you to identify correlations and the data characteristics that guide further processing. Then next step is concatenating all the data sets. All the individual data sets are combined into one unified data set, which makes it easier to work with and analyze as a whole. The next step is data pre-processing. In this step, missing values are handled by filling or removing them, and categorical data is converted into numerical format using label encoding, preparing the data for machine learning. Then comes the visualization part. Bar graphs are used to visualize the distribution of different events types in the dataset, helping to identify trends and anomalies. Then comes the feature extraction. TF-IDF is applied to both the original features and refined event messages, transforming the text into numerical vectors that can be used by machine learning algorithms. And then comes the SMOTE, that is synthetic minority oversampling technique. SMOTE is used to oversample minority class in the data set, addressing class imbalance and ensuring that model doesn't become biased towards the majority class. Then comes the data splitting. The dataset is divided into two sets. One is training and the other one is testing. Training has 80% of the total dataset and testing has 20% of the total dataset to ensure that the model can be trained on one subset and evaluated on the other to measure its performance. Then comes the model training part. Various machine learning models are trained using the training dataset to learn patterns and relationships in the data. Performance evaluation comparison. After training the models, their performance is evaluated using metrics called accuracy, precision, recall, and FN score, and the best performing model is selected for the future use. Coming to front end, a user interface is created using Flask, which includes features like user registration, login, and SQLite database is used to store the user credentials. And in the front end, user interact with the system by providing input through the front end interface by submitting logs and other data. And that given log, the user input is pre-processed to match the format expected by the model, ensuring that input is ready for prediction. After that, the trained machine learning model is used to make predictions based on pre-processed user input. The final result of the prediction is displayed to the user through the front end, providing insights or classifications based on the input provided. So this is how we have implemented the project. Moving on to the algorithms used. So these are all the algorithms used in this project. So here KNN, random forest, ADA boost, decision tree are trained on original as well as proposed features. Moving on to the extension, XGBoost is trained on the original set and LightGBM is trained on the proposed set. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap. So this is overview of the project. Now we have to execute. To execute, we need to open the code folder that contains source code files. So let us open the code folder. So these are the source code files in the code folder of the project. Here in the first folder, we have total 6 different files. This is the last test case file. Excluding this, we have total 6 files that are concatenated in the code. Then we get the final data set. So this is that data set, the final data set. So this is the final data set after concatenating all the files. So this data is used to train the models so that it will be able to classify the log files. Now let's close this. And coming to this model folder, in this folder we have the algorithm information that is stored in .h5 files, numpy files, and pickle files that will be loaded into the project during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And in this folder, that is templates folder, it contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And in this app.py file, this .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the notebook file. This is the Jupyter notebook file, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. We have understood all the files of the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the command prompt. So open the command prompt, give the command cd followed by the space and paste the copied path. Now click on enter. So by giving this command, current directory is changed to the code folders path. Now we are supposed to compile app.py file. So give the command python space app.py and click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host, that is 127.0.01, and the port is 5000. And now we are supposed to copy this local link provided by the Flask framework. So copy it and paste it into any web browser. I prefer Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project which is displayed in the browser. So this is the web page. Now click on register. Click on register. So here we are supposed to enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on I'm already member. As I have an account, I'm directly signing in. Give your username and the password to get signed in. Click on login. We have logged in successfully and we are redirected to prediction page. So here you can see a choose file button, right? We need to click on that for uploading the test case file. Before that, let's see what do we have in the test case. So let us open it. Open the data set. So this is the file that we're going to upload. So let's open it. So these are the total different features. Let's understand them. Here we have is the line ID. It is a unique identifier for each log entry in the dataset. This helps to distinguish and reference specific lines in the log file. Then we have is the label. It is the class label or the status associated with the log entry, that is normal or anomaly. This is useful for supervised learning for classification tasks. Then we have is a timestamp. It is a numerical representation of the time when the log event was recorded, used for temporal analysis or ordering events chronologically. Then we have the date. It is a specific date of the log event that helps in identifying patterns or trends over specific periods. Then comes the node. It is the hardware or the system node where the log event was generated, useful for distributed systems to identify which node encountered the event. Then comes the time. It is the exact time with possible milliseconds when the log entry was recorded. It helps to pinpoint event to finer temporal resolution. Then node repeat. It indicates repetitions or redundancies of events in the same node, useful for identifying recurring issues or anomalies. Then comes the type. It is a category or the type of the log entry. Helps in filtering and analyzing specific types of logs. Then comes the component. It is a system or the application component responsible for the event. For example, it's a cache memory, assisting in isolating issues within specific parts of the system. Then comes the level. It is the severity level of the log, essential for prioritizing critical issues in the logs. Then we have the content. It is the descriptive message or details about the event, core information for understanding the nature of the event. So this event ID is a target class that we will be predicting in the front end. So we will be excluding this label this column, and the system takes input of all other features, and then it will be predicting the event ID. That means the log file belongs to which type of event it is. And the last second column we have is the event template. It is a generic structure of the log message with placeholders for dynamic content that is useful for analyzing common patterns across logs. Then the last column is PID, that is nothing but process ID. This is the ID of the process that generated the log entry, useful for correlating logs with specific process or tasks. So this is about the test case file. Let's get back to the application. Click on choose file. We are supposed to upload this file. So click on that, click on open, and now click on upload. And the given input, it will be pre-processed at the backend, and then we will be getting the prediction. So here we got the prediction for all the test cases that we have uploaded. In the file which we have uploaded, it has all these test cases. So for the first event message, so this is the event message. Here it has predicted as it belongs to the E67 log file. So it has classified as E67 log file. Similarly, for the second message also, that is the second log file event also, it has classified as it belongs to the event 67. Accordingly, for all the other log files, so for this log file that we have uploaded, here we got the prediction as E4. Accordingly, for all the files that we have uploaded, it has predicted that it belongs to which type of event, whether it is E11, E6, E4, E67, it may be any of the event that belongs to a log file. So it is classifying the events based on the IDs. Now, let's check with the graphs. Click on graph. So here we have the graphs. The first graph is the accuracy score comparison graph. So this is the accuracy score comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithm names that are trained on the log dataset to classify the log events. So these are the models that are used to train the model. And here, this is the precision score comparison graph. Here also on x-axis we have precision score, and on y-axis we have all the algorithm names. This is the recall score, and this is the F1 score. So these are the metrics, that is accuracy, precision, recall, and F1 score are the metrics used to evaluate all the classification models. Now click on logout. In this switches, by giving the log file or the log event to the system, it will classify it belongs to which type of log event it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.